Okay, well, let's get started. My name is Tom Eichner. I'm the chair of the Cienega Watershed Partnership Board and your host today for this Lunch and Learn with Ian Murray and Julia Fonseca from the county. We're going to be talking about drought and resiliency in the watershed, and I think particularly on the various county lands that are part and parcel of the watershed. They both they work for the county and do work on various conservation and restoration efforts, and I think we'll hear more about that from them. So without further ado, I believe, Ian, you're going to be starting, right?
That's right.
So I will stop sharing to let you take over. So.
Okay, thank you, Tom.
Tom, do you want to record?
Oh, I already restarted the recording. Thank you. Yeah.
So hi, everyone. I'm Ian Murray. I'm a biologist here in Pima County's Office of Sustainability and Conservation, and together with Julia, as well as many other folks within, as well as outside of our department, we work on ecological monitoring of our conservation lands and stewardship, and just ensuring that we keep a close eye on what's going on and near our conservation lands. Here you're seeing some images of Cienega Creek Natural Preserve just upstream of the Del Lago Diversion Dam from this spring. So it's looking like, unfortunately, a lot of these cottonwoods that died back in 2020, even given the good monsoons of 2021, or they may not come back. And can folks see my cursor here?
Yes.
Yes.
So you can see that there's a green canopy downstream. You're looking downstream towards the Del Lago Diversion Dam here, but it seems like we may have lost quite a bit of canopy, and that has real repercussions for things like raptors. It's probably a zone-tailed hawk nest there, and with no canopy, thermoregulation becomes a lot more difficult for the young in the nest. So in this talk, we're going to talk a little bit about our climate monitoring. You'll hear a little bit about key riparian species that we monitor, including cuckoos, leopard frogs, and native fish. Julia will then take over and tell you a little bit about the climate change risks and trends, specifically as it relates to things like vegetation communities and erosion. And then we'll cap the talk off with some strategies for resilience. So Pima County's climate monitoring is centered on a vegetation and soil monitoring plots that we've partnered with NPS and Tucson Audubon in setting up. You're seeing here a map in light green of Pima County's conservation lands. And we've established about 100 of these soil and vegetation plots scattered across county lands and roughly organized by region. So here we have the Southeast region, for example, where Cienega Creek is, as well as strata. No need to pay too much attention to the symbols, but just know that the different symbols correspond with different elevations. So you can think of them as ranging from desert scrub to Madrean woodland vegetation. When we talk about climate monitoring, we're mostly looking at retrospective analyses where we leverage things like interpolated grid-based climate products like PRISM, where we can get max, min, and mean temperatures, as well as monthly precipitation, roughly on a 4-kilometer grid cell. And so here I'm showing you a graph where each colored line represents a region. So recall the Cienega Creek area was in the Southeast region. That's this green line. You're seeing plotted in 5-year bins. So this is most recent. This goes back to about 1981, which is the limit for PRISM data. You're seeing the mean monsoon precipitation. So essentially from 1980 through 2021. And again, in 5-year bins by region. So you can see that there really isn't a trend when we plot it out. You can also see that the highest amount of monsoon precipitation is in the Southwest region. So think Altar Valley. And the second highest is the green line. And again, that's the Cienega Creek area. And so when we do a more robust analysis of this data, we can look at trends separated out by region. So here you're seeing the annual trend here. So this is annual 1980 to 2021 in monsoon precipitation for the southeast region only. And we can look at a very commonly used analysis to look for a trend in time series called the Mann-Kendall trend test. And that test spits out essentially a figure called tau, which it ranges from -1, meaning a perfect negative correlation, to +1, the perfect positive trend. And you get a Sen slope. The slope you could think of as the rate of change over time. And so again, when we plot out the annual data for the southeast region for the monsoon, again, you can see there's no trend. There's a lot of variability, no significance as seen by our p-value. There's no change in monsoon precipitation in this region. However, we get a slightly different scenario when we look at winter precipitation. So this is precipitation from October to May, essentially. And again, I'm showing you a plot here. The x-axis is 5-year bins, so extending from about 1980 through 2021. You're looking at winter precipitation averaged across all of these plots within each region. And recall the green line is the Cienega Creek region. So two things to point out: there's pretty marked agreement in the trend across all of county conservation lands, perhaps not surprising given the tendency for winter precipitation to come in the form of larger, more widespread fronts. And you're also seeing there is an abrupt decline sort of extending through the late 90s, early 2000s, and from about early 2000s, late 90s, there hasn't been much trend. It's been a universally low amount of winter precipitation across all regions, including the green line again, which is the area where Cienega Creek is in. Now, when we pull out the annual data here, so on the x-axis, we have annual data from 1980 to 2020, winter precipitation. This is for just the southeast region. We can look at the same time series trend test, our Mann-Kendall test. We see that tau is about -0.3. That means it's a pretty strong negative trend, significant p-value there. And we see our Sen slope, which is the rate of change over time, is -3.3. So that translates into, on average, a decline of 3 millimeters per year in winter precipitation in this southeast region. And that's roughly the case for all of our other regions as well. So now let's look at some specific riparian species that our program looks after. So we have the yellow-billed cuckoo, an important songbird that breeds in these cottonwood willow, mesquite bosque areas. We monitor cuckoos both in Cienega Creek and in the Bingham Cienega on the San Pedro. I'm going to talk to you about the Cienega Creek monitoring here. We monitor cuckoos every 3 years. So here you're going to see data from 2017, which was a year where we had almost 9 inches of monsoon rainfall, versus 2020, where we had almost a failure of monsoon rainfall, just under 2 inches in the area. The graph is showing you our survey period, which extends from June to August. And on the y-axis, you're seeing numbers of detections of birds. The black bars are 2017 detections in Cienega Creek, and the gray bars are detections in the same areas, same points in 2020. So a couple things to note. In June and July, it doesn't really seem like there's much difference between the years. There's a little bit of variability here, but then that variability kind of evens out in July when you compare the 2 years. But once you look at the latter part of the survey season, so mid-July through early August, the black bars, which are bird detections in 2017, remain fairly high, whereas we almost don't detect any birds in 2020 on these sites. In August, we detected 1 bird, whereas in 2017, we detected 10. So that's a pretty big difference there. And if we look at breeding season rainfall spread amongst the 2 years, it's interesting. The gray bar, which is in 2020, we actually had more rainfall preceding the breeding season than we did in 2017. But then that shifted, and by the time the summer came, the black bar, again, that's 2017, we had a huge amount of monsoon rainfall in Cienega Creek, whereas in 2020, we had almost no rainfall. Not surprisingly, the wet dry lengths kind of reflect that. So in 2020 here, we have the length of flow in June versus September. And in 2020, we had less flow in September than in June, and it shouldn't be that way, but it was a pretty low amount of flow. I have this note here just to point out that cuckoos aren't only responding to the riparian stringer of vegetation when they make decisions about nesting, they're also assessing the greenery and concomitant arthropod abundance in the adjacent uplands where they also forage in. So again, for cuckoos, we had similar numbers of detections in 2017 and 2020 in the first half of the season, but in Cienega Creek, almost 90% fewer in the latter part of the summer. And I didn't show you the Bingham Cienega data, but we saw about half the detections in Bingham Cienega in 2020 as compared to 2017. Now we're going to repeat these surveys in 2023, and other partners such as Fish and Wildlife and Game and Fish are going to be working on a range-wide status assessment this year, where they will be including some points in Cienega Creek. So we will have eyes on the ground this year as well. So it'll be interesting to see what's there. So I'm going to jump a little bit north. So I'm going to show you a pretty key riparian area in Pima County's Buman and Bullock Canyons here. So the east flank of the Catalina Mountains, it's a tributary to the San Pedro River. And I'm going to show you some trends in longfin dace, which is a native minnow, and lowland leopard frogs. So Buman Canyon, of course, is a highly variable stream environment. This is a set of pictures essentially showing one key area and how it changed between 2014 and 2020. So the yellow circle is your landmark. And essentially in 2020, what was previously a very large, expansive pool and flow area almost shrunk to the size of a bathtub, and most of the fish and frogs were in this really small volume of water. There's a spring here. You can see the maidenhair fern. So we monitor the flow in this and other systems every June. So I'm going to show you a graph here. On the x-axis, we have year, and these are June measurements. So we're going back from 2015 to 2021. On this y-axis here, you're seeing mean rainfall. And on this y-axis, you're seeing the length of June flow that we measure. So a couple things, the black dots are the flow in Buman Canyon in June. The red dots and white circles are the flow in Bullock Canyon, which is a small tributary to Buman. And so Buman's a much bigger system. You can see in 2019 and 2020, we had almost a mile of surface flow. Bullock changes less, although it did have a peak flow of about 250 meters during those 2 years. And the bars are in dark, the mean summer precipitation, and in light gray, you're seeing the mean winter precipitation preceding a June wet dry. So I'd like to point out that these peak flows, especially in Buman, are preceded by fairly high winter precipitation. High summer precipitation doesn't really seem to be being reflected in the system quite as much as those winter precipitations the previous season. And these graphs essentially a little bit more quantitatively show that relationship. The left graph is Buman Canyon flow. The right is Bullock Canyon flow. Here you're seeing the length of flow on the y-axis and the winter precipitation the prior year on the x-axis. And these plots with 95% confidence intervals are essentially showing that there's a pretty good correlation between good amounts of flow in June and rainfall the preceding winter. And we also did these lag regressions looking at winter precipitation, for example, 2 years before or 3 years before. And it was really just a year before it sprung out as being the most significant. So not surprising, but it's still good to see the relationship. So when we do these wet-dry mapping adventures, we're also recording observations of leopard frogs and longfin dace, as well as many other key species. Here you're seeing a line representing Buman Canyon here, and this small tributary is Bullock Canyon. And in the green dots, you're seeing observations of lowland leopard frogs that we made from about 2011 to 2014. Lavender dots are observations we made in 2015 when we started to standardize a little bit more the areas we looked at. So the point here is that they're pretty well distributed throughout the system. Now in blue, we have observations of frogs in 2016, and in orange, we have observations in 2017. Again, the observations are well spaced throughout the system, and we even pick up some observations of frogs in the upper part of Buman, which doesn't have a lot of habitat. But in 2018, in the green dots, in 2019, in the red dots, you can see that we've lost leopard frogs in upper Buman Canyon, but we still have good redundancy and representation in the rest of the system. That changes in 2020, yellow dots, and in 2021, the purple dots. So importantly, in 2021, we never regained occupancy in upper Buman Canyon. And we didn't detect any leopard frogs in this lower part of Buman Canyon, which historically is home to hundreds, likely thousands of leopard frogs. I circled this dot here because this was an incidental observation from during the monsoon in 2021 that another staff person made of calling leopard frogs. In June 2021, this was all dry. And key to point out that Bullock Canyon continues to harbor leopard frogs. So we'll see what the status is this June. And I didn't show you what we saw for dace, but the tables here kind of wrap up what we've seen for dace and leopard frogs in these two systems. You can see the tables encapsulate observations that we've made for dace and leopard frogs in the two canyons, bin by year. And I want to just quickly point out that for dace, we lost the population in Buman and Bullock Canyon that had been there for many, many years. In 2020, it finally winked out. We haven't lost leopard frog populations as a whole, but we very clearly have reduced areas occupied by leopard frogs, as seen here. Buman Canyon in 2021, there was one site that we detected leopard frogs. That was that incidental observation. In Bullock Canyon, there were 3 sites, essentially 2 small pools. So really, we're seeing a reduction in population resiliency from these data. We haven't lost occupancy, but it just makes the populations a lot more vulnerable to stochastic events like big flows. So I'm going to take you back to Cienega Creek. We're going to look at some data we have on Gila, or now it's called roundtail chub in the lower part of Cienega Creek. So we have observations of this species centered on large pools in essentially 5 areas in the Cienega Creek Preserve. This is the Three Bridges area. My cursor is moving upstream. This is the Horseshoe Bend area. And chub have been spotted in essentially 5 different areas. The preserve really is marginal for chub. They like much deeper waters with undercut banks in some examples. There's not a whole lot of that in the preserve. There's much better habitat further upstream on BLM lands. But be it as it may, we have a fair number of observations of chub, particularly centered on a key pool, a single pool, where we had pretty repeatable observations in this area of the Horseshoe Bend, which is a pretty key stretch of permanent waters in the preserve. And so we and PAG and others made observations of chub in the preserve from 2006 to 2018. Again, the chub were seen in only 5 different pool areas, and that chub pool, that area in the Horseshoe Bend, was the most important site. And by August 2020, most of the pools had really all dried up, and there was really mostly just very shallow run type habitat left over, areas not favored by chub. So here you're seeing this chub pool. This is where most of the observations were from. In July 2020, this was pretty tiny. You could pretty much stretch a net throughout the whole length of that pool. It was small. But by September 2020, we had 1 or 2 good rains in the upper watershed. That pool started to refill such that it was a much bigger system. So if you had not had a regular presence in that system before those rains, and you only happened upon it in September 2020, you would say, oh, wow, the habitat's great. Look at this huge pool. There's got to be chub in here. But since we were doing cuckoo surveys every few weeks, we were there quite frequently. And we saw that pool became disconnected from the upstream stretch, disconnected from the downstream stretch, and it was tiny. There were not chub in there. And indeed, we worked with others to put baited fish traps here in 2020, as well as a few other pools that had reformed, and we did not detect chub. So with that, maybe if there are any questions, I'm happy to take some questions, and otherwise I'll hand it over to my colleague Julia.
Ian, did you want to answer some questions in between, or?
If folks have some questions, I'm happy to discuss those.
Yeah, I mean, one question came up, sort of the variability that you're seeing, right? You have this records that go back to 1980 or so. What's your sense of how that variability works back farther in paleo time, the last couple thousand years? I'm just trying to think of these, right? These highly valuable aquatic systems that you've shown have in some cases collapsed. Sort of how much they've seen shocks like this before, and how much of it is due to either hydrologic alteration, or I think in the case of the stuff on the north side of the Catalinas, probably climate change. So
yeah, that's a good question. And Julia, if you don't mind me leaning on you, I might lean on your expertise and long span of experience there.
Yeah, so back in the early 1900s, there's a US Geological Survey map that showed perennial flow extending from basically all through the preserve and down basically halfway to the Rincon Creek.
okay.
Now, you know, was it really perennial? Maybe it was intermittent. But historically, if we go back even further, prior to 1880, the Cienega Creek Natural Preserve really was a cienega. It did have, you know, grass on the uplands, grass in the bottomlands, copses of cottonwood, some mesquite, especially on tributaries, not so much on the floodplain. And then there was a major entrenchment. So the system hydrologically has really changed starting in 1880.
Right.
And with the lowering of the water table by the Arroyo incision,
Right.
that was a profound change. So by about 1935, which was the first aerial photographs that we have, you can see that the former floodplain is mostly mesquite. And you can see that there is flow in Cienega Creek in the preserve for the most part.
Yeah.
Certainly in the 1980s, you know, after the 83 flood, it ran past Vail for months and months and months. The school buses had to take a long detour to get around the Colossal Cave Road Bridge. So there was a major event, you know, recharging in 1983.
Right. Yeah. Okay.
So in terms of, you know, the baseline that, you know, some of us encountered, we encountered, you know, and coming into this system in the 80s, something really regionally, it was a regional recharge event.
Right.
So a lot of the streams were flowing a lot more.
Yeah, that wet stand that really starts in the 60s and goes to the early 90s, but it's punctuated with the 83 tropical storm and the 93 El Nino. Right. As you're saying, it colors a lot of our perspectives about how wet this place is, and the biology that could support. And so it becomes difficult to tease out how much of what we're seeing is a traditional aspect of, we know that there have been these long-term droughts from the triggering record, but there seems to be things here that are different as well.
Yeah, well, we
So,
know that it's a lot hotter.
Yeah.
And we also know, from tree ring studies that this is a mega drought. I mean, it's
Right.
hotter and drier than it's been in more
Yeah.
than 1,000 years
Yeah, this is I mean,
regionally.
yeah, regionally, this drought does not seem to exist in our robust tree ring record back to about 1,000 AD. So, yeah. Okay. Yeah, go ahead and pick up, Julia, if you want.
Okay, do we have any more questions?
Yeah. Sounds like not for now. So
Okay.
I'm sure we'll have more later. So.
All right, I'll try it here. So you've hopefully you're seeing my screen now. Is that right?
Yes.
Yes.
Good. Okay, so you've heard from Ian quite a bit about the effects of drought on our wildlife in different riparian areas. So going forward, I want to talk about some changes that might be coming our way in terms of, either what we're already seeing, what's the evidence for these things, or what we might see. I will say that, we've been participating, Pima County and many other water supply jurisdictions have been participating with the Bureau of Reclamation on some climate change scenarios, trying to understand what those mean for regional water supplies. And, in terms of surface water runoff, starting with the trends in precipitation, to kind of continue what we've seen since the 80s, which is basically, this declining winter rainfall from a high in the like 1983, obviously that in 84 very wet, to what it is today. So some of the scenarios for the future include less winter precip, more variable monsoonal precip, which is of interest for this watershed because this watershed really responds to summer runoff. All of the floods of record have been generated by either summer monsoonal floods or dissipating tropical cyclones in September or October. So let's see, go forward. Guess I have to click it over here. Okay, so in terms of broadleaf forest trends, you've already seen some really heartbreaking photos from around the Agua Verde confluence area. We started seeing loss of some of those trees back in the 2006, 7, 8. We started to see quite a bit of loss of cottonwoods and some of these older mesquites on terraces. Tyson Sweat and others did some analysis using LIDAR within the preserve. And this was based on, I believe, comparisons of LIDAR from 2011 and 2008. And they were seeing the largest cottonwoods. They're in the best watered areas as gaining. And so that's represented over here during that time period. But losing some of the mesquite, that was the thing that was more apparent, these shorter trees and in positions that were elevated above the water table. Since then, between 2013 and 2019, I was down in the creek bottom every month looking for evidence of cottonwood recruitment. And I did see some seedling trees come up one year, but I did not see any recruitment of cottonwood during that time period. And then we got the monsoon, we call it, of 2020, again, no recruitment. So the question is now, with the elevated flows that we're seeing right now, are we going to see successful recruitment? The timing of these elevated flows is not good. Cottonwoods tend to do a pulse of seeding in the springtime. So we can look for that this springtime and see if they are going to establish and then persist. That is a real question. Are we going to be able to replace some of the cottonwoods that we've lost? Now, having said that, we do see, I do see a lot of ash trees that of all different ages that have come in. Hackberry is still coming in, walnuts are still coming in, and of course mesquites, plenty of recruitment there as well. Another thing that we've done recently is to remap the vegetation communities using recent aerial photographs, field knowledge, and then also what we call a supervised classification of 4-color, what was it, National Agricultural Inventory Project data. And what's happened between 1994, which was the last vegetation community mapping we had, and today, is basically there is a lot of channel narrowing. The channel has narrowed from the establishment of the burrow brush community, which is also called Hymenochlea monogyra, if you like scientific names. And then the growth in the cottonwood canopy and the well-watered areas that had occurred before the monsoon of 2020. So a lot of, some of that has been removed by the large flood. There was a large flood in 2021 that was the largest flood since, I think, 1998, or I mean, 1988. So that also removed quite a bit of vegetation. So this remapping was only really good, for the time period that's mentioned here. But the other thing that we see in the vegetation mapping is shown in this patch here of red, and there's a couple of other small, tiny patches of red. These are exotic grass communities that really weren't around in the 1990s. This particular one is dominated by Johnson grass. There's some other exotic grasses as well. So that's a new vegetation community type for our preserve. And that is not welcome, welcome news. I recently completed a flora, which is where you go out and you try to identify all of the plants that occur in a given area and look at the diversity. And we were fortunate to have quite a bit of collection back in the 80s, 90s, and early 2000s. So what I did is I looked for whether the wetland species that were known to the preserve in those previous decades were still around. That was one of the things I looked at. I found 16, or I failed to identify 16 different wetland species that had previously been detected in the preserve. Now, it's possible that I overlooked them. A lot of those wetland species are rather small and hard to find. But I also know that some of these species that were detected in the earlier days, such as this Huachuca water umpel, were not persistent members of the plant community there. The year that this Huachuca water umpel was found in the preserve, the very next year, a flood carried that patch away, and we were never able to find any more examples of this particular species. I also know that there are new wetland species that show up in the preserve. Ian and I were out one day with Michael Bogan looking at macroinvertebrates, and two of the things that we saw, 2 new species of wetland plants right by where we were sampling. Variella erecta, which is common in the upper Cienega in the BLM area. And then this broadleaf Typha latifolia, it's a type of cattail, but it's different than the one that is usually in the preserve. So we know that wetland species are coming and going in the preserve. So it's a little difficult to draw a conclusion that this is a trend, but nonetheless, 16 wetland species is something significant. We also know that Julie Stromberg and her students did some soil sample removal from the preserve. They grew out what was in the seed bank in the soils, and they found a number of species that do occur and are brought into the preserve from points farther up in the watershed. So this movement of soils and seeds from other places is part of the potential for resilience in times of drought. We hope that animals, wind, and water will continue to bring in plants to the area to recolonize. Riparian areas, because they are affected by floods, they scour new substrates, they open up canopies to sunlight. So they inherently create a lot of spaces for colonization. And of course, those floods also help irrigate the new plants. So one of the things that surprised me, I guess, in doing this floral analysis was to find out that it does not look like I'll ever be able to fully catalog the species diversity within the 4,000 plus acres of the Cienega Preserve. This is a graph that shows the field hours that I and other volunteers logged collecting plants, and then the number of species recorded on the vertical axis. And there's pretty much a one-to-one relationship there. So even though we logged over 500 species of plants, it looks like they're coming and going, and we will never be able to fully characterize the potential of the area. In the uplands, particularly during drought conditions like we've been having, areas will open up to be colonized as established plants die. So one of the things that we might see in the future is more rapid turnover of vegetation. The plots that Ian and others are establishing with the National Park Service and help from Tucson Audubon are going to look at how the upland vegetation changes over time. Now they'll just be looking at the perennial vegetation, but that will tell us a lot about whether our plant communities and the soils that are underneath them are going to change. One of the things that we know from these climate change scenarios and the trend that we've already seen is that we are getting warmer. And this particular area is right in the zone where damaging frosts have historically limited the distribution of a number of plant species, particularly along the bottomlands, which tend to get these cold air drainage phenomena. Very cold in the bottomlands during the winter, even when it may be comfortable up in the uplands. So one prediction would have that we would get an increased number of species that have been previously limited by freezing. I will say that I am seeing brittlebush in the preserve in places that I don't know if they were there. They're very small colonies. There are observations of, let's see, what was it? It was coral beans coming into the preserve with floods, but they don't establish because it's too cold. And lately we're starting to see quite a bit of tree tobacco, which is a South American non-native species. That one I don't think it's going to become a terribly dominant plant. It's going to be in small numbers probably, but it seems to be getting a broader distribution in the bottomlands than I used to see. We are seeing bufflegrass, an increased distribution of bufflegrass. There was a Pima Association of Governments survey of non-native species in the preserve in 2003. And that was part of the focus of their efforts. So there's good evidence for increased buffalo grass. And then Johnson grass is really spread there, as well as in the San Pedro River. I see quite a bit more Johnson grass than I used to. We are concerned about those species, but also the arundo. This is the furthest upstream that we know of arundo occurring, and the flood control district has been on it. There's small amounts of arundo, but they have definitely been removing the plants as they see them. There is one clump left in the preserve that is underneath a giant dead cottonwood tree, and so it makes it difficult to really get at you need to get the roots of this plant if you're going to remove it. So in the flora that I've done recently, there are some non-natives that were not previously detected. It's a little difficult to tell if they're really new or they were just overlooked, and they're only present in small numbers. Are we seeing increased fire frequencies? Well, we certainly are seeing fires happen around the preserve. There was one recent recreational fire within the preserve that had to do with some unauthorized nighttime activities. What we can say is that the current conditions are certainly ripe. The ample monsoonal rains of last summer have left a lot of fine fuels in many, many areas along the roadways and elsewhere. So the conditions are certainly ripe for seeing more fire. But in the past, it's not been a big force affecting the plant communities and habitat in the preserve. In the recent past, I should say, meaning 40 years or so. So what about upland soil erosion? And if upland soil erosion is happening, is it being deposited in the channel? This is an interesting situation. We have site stewards that go out and look at certain parts of the preserve that have archaeological resources. And one of the things they do is they look at the amount of soil erosion that's affecting the distribution of artifacts, potsherds and the like. And there's about 20-25 years of records from these site stewards that were recently analyzed by our cultural resource team. And they noted that the site stewards believe that increased upland vegetation cover has helped reduce soil erosion over the decades, and particularly over the time period that we got rid of livestock. So that was mainly post 1990. Most of the livestock were removed from the preserve, and so the resulting upland vegetation cover has stemmed some soil erosion, although I do see plenty of evidence for soil moving into the channel. There is no evidence that I have been able to see for long-term aggradational trends in the bottom of the channel. Now we do see localized things like this pool, for instance. It gets opened by flooding and then it'll get sedimented in over and over again. But there's two places where we have long reaches that have been monitored. One is down by Colossal Cave Road, another one at the Marsh Station Road Bridge area. And in those areas, we do not see any evidence for long-term raising of the channel bed by sedimentation. But this photo from 1964 is at the Pantano Dam. There's a stream gauge there. And usually there's about a 10-foot drop over that feature. But in the 1960s, the channel below the dam filled all the way back to the top. So it shows you what is possible. So what can be done to improve the resilience of these systems? Well, it may seem odd or counterintuitive, but one thing that can be done is to basically allow nature to do what it does well, and that is to erode sediment. And you think, well, that causes loss of this vegetation on the outside part of the bend, and that's certainly true. But what is this less obvious is that there is building up of sediment over here on the inside of these bends, and aggradation. Sediment gets removed here and it gets stored and piled up in this area. This basically lowers, the erosion is lowering the land surface and making it more accessible to soil, to the floodwaters reaching it. So when I look at a stream bank like this with these dying mesquite trees that are from the 1930s and 20s, that's when they established, maybe even earlier, they're out of sync with the current climate. And really one of the best things that can happen to that plant community is for that surface to be lowered into the floodplain so floodwaters can access it and restore it naturally. Now there is also a manual that basically encourages people to induce stream channel meandering to basically, again, lower the land surface and make it accessible to floodwaters. Another strategy that's being proposed and hopefully will be tested in the upper Cienega Creek area, Cienega Creek watershed, will be looking at the potential to increase the storage of water in the stream banks using beaver dams. Another possibility is to use what's called BDAs, or beaver dam analogs. It's not something that I've heard of being used here locally, but perhaps that's in the future. Again, it'll be important to get some monitoring data to find out, how well beavers can help rewater a particular area. And one of the challenges for beavers in the San Pedro River has been predation and lack of sufficient numbers. So will the Cienega Creek watershed be able to offer them a sustainable population size is certainly a question. We can do a lot with livestock management and Pima County has done a lot. During times of drought, which we've been limiting the amount of livestock that can be applied to the land, and even resting entire ranches from grazing after fires or during extreme drought. We've been improving the water distribution to the pastures and establishing more pasture rotations. What hasn't been tried yet, but is certainly something that could be tried in some areas, is to even try different livestock breeds. So the Criollo livestock that is a traditional type of animal used in Mexico is a lighter, it's a lighter cow, has a lighter footprint on the land. It requires less water per unit cow. So that may be something in the future. Another option might be to combine ranches into larger units to give more flexibility. So a lot of opportunities there for livestock management to improve soil and vegetation response. There's also a lot of possibilities to improve road management. Roads can be extremely damaging. I think La Cienegas has done a really nice job on managing their road systems, but there are a lot more rural roads in the watershed that need better design. And a lot of that has to do with trainings. So the Altar Valley Conservation Alliance has arranged for some joint trainings with our Department of Transportation in the past. And this is the type of thing that can really help minimize future erosion and dewatering of the landscape. Same thing can be done with trails. And in fact, in the Cienega Creek, the new corridor management study, one of the things it calls for is to identify and close some poorly designed trails and unneeded road beds that are used as trails, get those rehabilitated so that they're not contributing to erosion and aridification. The Cienega Creek Management Plan, or the revised corridor plan, has a new an expanded fire management chapter We've already done some good things by just restricting nighttime recreation, which tends to be accompanied by campfires. But we need to do more in terms of fuel monitoring and maintaining fire breaks. A lot of these fire breaks take advantage of existing roads and utility easements. But managing the exotic grass component is going to be important. And for that, we need continued help from our transportation department, as well as the state. The state's mowing along roadways is also very important. And then a lot of outreach with between us and the various fire districts that do the firefighting can help reduce the impacts of on soil and vegetation should a fire occur. Building new arcs. There are definitely quite a few of us in the watershed working on that, whether it's on our private lands or our public lands. Creating new wildlife waters is what people are doing, but also stocking new populations of top minnow, for instance. Building frog ponds is certainly something that's happening. And even lately, we've established, we hope, a new population of this very rare plant, the eryngium. And this summer, we hope to get to establishing a new population of Huachuca water umbel in the preserve. And finally, for resilience, another thing that we can do is to improve and maintain and improve the connectivity for terrestrial wildlife that runs through this area. It's a very important area for movement of wildlife, but the interstate produces some real challenges. Sky Island Alliance has been monitoring different structures underneath I-10, and these photographs are from some of their, I'm sorry, I said Sky Island, I meant the Coalition for Sonoran Desert Protection. So they found over 36 species using these structures, and they have some ideas for improvements that will be hopefully the basis for a future proposal to the Regional Transportation Authority on how to improve some of the wildlife movement across that interstate barrier. And back to water, we have opportunities also to restore diverted flows and keep a reduced level of pumping, but that's going to require working with the people who have the rights to those water. So some of you know that the waters of Cienega Creek are diverted at this dam structure to go to the golf course. Now, if the Rosemont mine is built, one of the mitigation measures for the Gila top minnow is to allow this flow to go back into the stream channel instead of diverting it. That's one of Rosemont's mitigation measures. And the Vail Water Company, which operates in the Colossal Cave Road area and supplies the water to that emerging community, they have an interconnection to Tucson Water now. And since, I think it was around 2015 or so, they got that interconnection. And it's allowed them to reduce the amount of pumping that they do in the lower Cienega Creek Preserve. So we're hoping that that is going to continue a trend in the groundwater levels at that lower end of the preserve. So here's some of the groundwater data. These are just for shallow wells, not deeper wells, over time, going back to 1994, and then going through to almost early 2021. And with the summer monsoons, we saw a tremendous improvement in some of these shallow wells along the creek, the ones that you would predict would be the most responsive. Now, these wells, let's see, PS1, that's one that is closer to the lower end of the preserve. It's the only one that might be responsive to the Vail Water Company's reduced pumping. And you can see that it started to go up around 2014. So I think that was when their interconnection came in. It stopped getting so low, but it's a gain of about 10 feet maybe for that interconnection. So the question is really for the Vail Water Company whether they will be able to maintain that reduced level of pumping despite rapid growth. And I think that's about it for us.
Thanks, Julia and Ian. It does look like Stu Williams has a couple questions in the chat. Basically, are there citation enforcement measures in place to alleviate degradation from sensitive habitat trespassing or non-public use violations?
So there are enforcement provisions in place, but there is very little attention to this particular area given by the Pima County Sheriff's Department. At one time, we had park rangers, and back in, was it 2006 or 7, I think, the park rangers were eliminated in favor of having the Sheriff's Department do that work. And while they have about $1 million worth of budget each year, a lot of that budget goes to search and rescue and to Tucson Mountain Park, a lot of unauthorized activities occurring, in more urban areas. We don't see a lot of enforcement by the Sheriff's Department or by Game and Fish, and we do have quite a bit of issues, I would say countywide, with off-road vehicles as well. So while there are provisions in place, there is not, in my opinion, the level of enforcement that we'd like to see. One of the new strategies in the Cienega Corridor Management Plan is to initiate what Parks is calling a Park Ambassador Program. And so that is a non-enforcement approach to just basically having people who are knowledgeable about the area around to interact with visitors and to show a presence of stewardship and concern about the resources that are there and help people get oriented and understand what they're seeing.
Yeah, and a question from Stu, and I'll sort of add to it, right? Right, the Del Lago diversion, I guess, how much water would that be if it were no longer diverted? What might the effect of that be? And the add-on to that is then essentially, what are there conversations about trying to replace that diversion, right, with other water? So.
Yeah, so the water right is 1,100 acre-feet per year, but nature has not been delivering that much water to that particular location. We might be talking about something from 400 to 800 acre-feet per year in terms of an actual gain, which is substantial. And, there is a reach of the creek downstream of the dam that will flow for longer periods of time if that water is restored. However, beyond a certain point, there's like an underground waterfall. I mean, basically the alluvium becomes extremely thick. You enter the Tucson Basin, and unless there would be a perching layer to keep the water up near the surface, I can't see why that would, I don't expect that to restore flow all the way to Vail.
Yeah, okay. That's
Ian, maybe you want to, I don't know if you want to say anything more about, how you think that would affect the, fish or frogs or anything.
There's a dam there, so any water below that would host fish, certainly, that are separated from areas above the dam. The fact that the dam is there works to our favor when you think about it is an impediment for certain invasive species moving higher up into the watershed. Our data I did not talk about today is some analysis of data we have on where species are seen in the preserve and where key sort of pool sites are. And for whatever reason, even though that diversion area has a pretty reliable pool as well as some flow there, it's surprisingly unimportant for lowland leopard frogs if you can index importance of leopard frogs based on the sheer number of tadpoles and juvenile and adult frogs you see. They're there, but through time, it's about 2005 to 2020, it's remarkable in how few of those life stage, the tadpoles and adult frogs we see at Del Lago.
It's pretty simple habitat. It's not very complex. It doesn't have the kind of off-channel shallow pools and, you know, a lot of vegetation complexity. So yeah, probably not as good for the leopard frogs. So another part of the question, I guess, was the return. Yeah, so the water would just go back to the stream bed, but the dam would be left in place under this scenario of, you know, Rosemont taking ownership of that surface water, right? And did that answer your question, Stu? Or was there more? Okay, that's good. All right.
I think Sheila had one more question.
Kind of a comment and question. It's kind of amazing that it happens together, but at the same time that you're reevaluating and recording archaeological sites on the preserve, we have a grant to record a sample of 25 sites at Las Cienegas. So we were out in the field on Las Cienegas April 6th, and we'll be out in the field on the preserve on April 21st. But your observation about the vegetation is interesting, because on the upland archaeological sites, you can hardly find them for the thick vegetation, the pigweed, mesquite, just a variety depending on the local situation. But we could see the artifacts once you knew where they are. The problem with relocating sites that haven't been looked at for years, where you don't have Arizona site stewards, is you don't exactly know where they are. So desert archaeology was able to find, I think, 24 of the 25 sites that we wanted relocated. So yeah, they're not in too bad shape. However, when you get to the channels, as you pointed out, some of your most significant sites with the most amount of materials are being eroded by those channels. So any kind of soil removal in the channel, these sites are buried so deep, is going to affect some very significant archaeological sites. And we had some good discussions about how do you protect those in channelization. And so that's where there's a real difference in what's going on in soil erosion and vegetation that we've seen so far, but we have more field visits to do.
Yeah, no, you're absolutely right. I mean, induced meandering, you know, if that goes right against a buried, you know, I mean, it could be a burial, it could be a, you know, or a lot of hearths and habitation sites. So and sometimes you can't know really what's back there, right? You know, until it's uncovered. So I mean, in fact, that's the way a lot of these archaeological sites are found, through natural exposure, through erosion.
And a counterpoint would be that spreading the creek out may prevent further incision that might also compromise those same sites. So it's not a simple, those channel sites I can see there's a lot of different trade-offs and trying to protect them. So
yeah, good points.
Yeah. I have one last question, Julie and Ian, and which is you know, from working with Julie myself, I know that it seems to me that the lower preserve benefits from that seed dispersal and maybe wildlife dispersal from upstream, bringing in replacements. Yeah. And I'm just wondering, sort of how much of a benefit do you think that is to, particularly to the seed bank, if the system does manage to wet up again from either reduced pumping, from induced meanders, or maybe one of these days we'll get a wetter climate period from our variable climate. So,
well, I'll comment, I guess, from a vegetation standpoint. I mean, I think the connections are, evident. in the change, the rapid change in, wetland vegetation. Seed is coming in all the time, and, even upland
Yeah,
species are colonizing.
yeah,
From local sites. So it's every day in every way practically on the vegetation
yeah. But
side.
I mean, Julie's shown really well this ability of upstream locations to dump seeds into lower downstream enables potentially real revivals during wet periods or from restoration.
Mhm. Yeah, and I will also say that although I don't intend to publish anything recent in the near future, I'm starting to look at the historic records, the ones that are back in the 1880s and 1900s. And again, there's a lot of collections on Davidson and Cienega because they were along routes of travel. They were easy to get to by the railroad and so forth. And there's not a lot of loss of species. There's been tremendous changes in the vegetation structure.
Right.
But the loss of species historically is not really, there's not many species that have been lost. And,
Yeah,
and that's kind of a little surprising.
Yeah, yeah, it is surprising. I mean, I think, but on your graph of 1-to-1, I'll note, Julia, I've heard you're retiring. So I assume you're going to be walking the stream every day during retirement, and you'll be able to find new species that way.
No, that's for somebody else.
That's a neat analysis that basically, if you want to know how many species are out there, you need to keep trying. And if you keep trying, you'll keep finding more, and you'll never be done.
Never be done, yeah.
With
Not in a stream system like this anyway.
Yeah, I mean, but it speaks to the real biotic diversity in these systems. That's, I think, it's hard to capture.
Yeah. On the fish side, I guess I would say, there were chub and top minnow in the upper Cienega for many years, and they never came down. I mean, maybe they came down, but they did not establish, in the preserve until the habitat was good enough for them.
Right.
I mean, people looked in the 80s. Arizona Game and Fish Department did a Gila top minnow reestablishment survey in the 1980s. They didn't end up putting any there, but the fish.
You need to have that habitat quality.
Gotta have the habitat,
Yeah.
Even if the source is there.
Right. Oh, we've seen that on the main stem of the Santa Cruz, where improving the water quality and the habitat has enabled native species to return where I think many of us thought they never would. So, yeah. Well, thank you again, Julia and Ian. I will note we will get this recording up on our YouTube page. May take a week or so. But thank you all very much for coming today. It was a great presentation, Julia and Ian. Very much appreciated. And we'll see you all again soon.
Thanks, everyone.
Bye.
Bye.
Bye-bye.